Hey guys, tonight we're journeying to one of the deepest, strangest, and most silent moments in our planet's history. We're going back 2.1 billion years to a time when the Earth was an alien world, to find the very first faint whisper of complex life. Imagine we are in the Rhyation period. Before you lies a hostile planet. The sky isn't blue. It's a hazy methane orange. The continents we know are gone, replaced by a single volcanic supercontinent. The air is thin and toxic. The world's nickname from this time, the Rhyation, literally translates to stream of lava. But in that darkness, in a shallow, muddy basin in what will one day be Gabon, Africa, scientists have found something. It's not a bone. It's not a shell. It's a structure. A small, disc-shaped impression in 2.1 billion-year-old black shale. Over decades of debate, this simple shape has threatened to tear up and rewrite the entire first chapter of our existence. It has ignited a scientific war over the very definition of life, pitting geologist against biologist. So what is this structure? Is it just a meaningless crystal, a pseudo-fossil formed by inorganic pyrite? Or is it the oldest multicellular eukaryote, our oldest ancestor, appearing 1.5 billion years too early? And if it is life, why did it vanish, leaving the planet to fall silent for another billion years? Thanks to new isotopic analysis and scanning electron microscopes, tonight we will explore this 2.1 billion-year-old question mark together. Frankly, if you were dropped here 2.1 billion years ago, you wouldn't just suffocate in the thin, methane-filled air. You'd be vaporized by a volcanic flow before you ever got the chance to complain about the view. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. That small click sends a big signal to the algorithm. That long-form, serious educational content still matters. And to me, it's an incredibly meaningful show of support. Thank you so much for helping keep this channel going strong. It always fascinates me to see where you're all tuning in from. Let me know in the comments where you are in the world and what time it is for you. Now, dim the lights. Maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. We begin not with a creature, but with a question mark. You are floating above an alien Earth, 2.1 billion years in the past. As we mentioned, this is the Rhyation period, a stream of lava. The oceans are global, and the atmosphere is choked with the Great Oxygenation Event, a catastrophe where new cyanobacteria are polluting the methane-rich air with a toxic, corrosive gas. Oxygen. This gas is killing off most of the planet's single-celled life. It's an apocalypse. And it's in this chaos that we journey down into a shallow sea in what is now Gabon in West Africa. We're sifting through layers of fine, black shale. And then we see them. They are the Francevillian biota. They don't look like much. Some are disc-like, just a few centimeters across. Others are elongated, like a small, lumpy string of pearls. A few, rarer ones, even seem to have a flower-like or lobed shape. The largest are up to 17 centimeters long. When scientists first unearthed these in 2010, the field of paleontology collectively froze. Because these weren't just imprints. They were structures. They had a distinct shape, a complex form, and they appeared in colonies. The team that found them made a bold, almost unbelievable claim. These were colonial organisms, multicellular eukaryotes. To understand why this is so world-shattering, you have to know that the accepted first large multicellular life on Earth the Ediacaran Biota, doesn't show up until around 600 million years ago. These structures from Gabon are 2.1 billion years old. They are 1.5 billion years too early. This discovery shatters the timeline of life. It suggests that Earth didn't just invent complex multicellular life once. It invented it, and then lost it. Immediately, the scientific war began. Geologists fired back, arguing that these are not fossils. They are pseudo-fossils. They argued that these life forms are just inorganic pyrite, fool's gold, crystallizing in a weird disc-like shape, or that they are artifacts of diagenesis, just the way the mud happened to smear as it hardened into rock. The pro-life side returned fire. They used isotopic analysis on the structures. They found that the fossils were enriched with specific isotopes, particularly zinc, in a way that was consistent with eukaryotic metabolism. This wasn't just a random rock. This was something that was processing chemicals. The pro-rock remains unconvinced, arguing the chemical signature isn't definitive. And so, the entire field of paleontology is left holding its breath, staring at these silent 2.1 billion year old stones. We don't know if we are looking at a geological curiosity, or if we are looking at our oldest, most distant ancestor. This profound ambiguity, this silence, is the real story of early life. Because after this potential first experiment, this false start, the world falls quiet. The Francevilian biota vanishes, if it was ever there at all. And the planet enters a new phase. A phase that will last for 1,000 million years. The world falls quiet. The potential experiment of the Francevilian biota is gone, leaving no echo. You are now drifting into an age so vast and seemingly uneventful that scientists, with a characteristic dash of academic wit, have named it the Boring Billion. This is the Proterozoic eon, stretching from roughly 1.8 billion to 800 million years ago. 1,000 million years of not much. You are floating in a vast, planet-wide ocean. The water feels sterile. The sky above is a pale, hazy orange, still thick with methane. You are adrift for 10 million years, 50 million, 300 million, and nothing changes. The view is the same. The continents beneath you are locked into a single massive supercontinent, which we call Columbia, or Nuna. And it's not going anywhere. Tectonic activity, the planet's great recycling engine, has stalled. The world is holding its breath. This world isn't dead. Not really. But it is stagnant. The only life here is a thin, invisible soup of microbes. Down on the shallow seafloor, there is action, but it's not what you'd call thrilling. Vast, slimy mats of cyanobacteria are carpeting the coastlines, quietly, patiently, photosynthesizing. They are pumping out oxygen, just as they did during the rhiation. But that oxygen isn't building up in the air. It's instantly soaked up by the iron-rich ocean, where it bonds to the dissolved iron and just rains down as rust. For 1 billion years, the planet is just rusting. Why? Why was the world so boring for so long? This is one of the most profound debates in paleontology. Scholars still argue over what put the brakes on evolution. Was the atmosphere just too low in oxygen, unable to support the high-energy lifestyle of a complex animal? Were all the vital nutrients, like phosphorus, the P in ATP, the very battery of life, locked away in the rocks, starving life before it could get started? or perhaps most chillingly, was evolution itself just stuck? Had life hit a complexity wall, unable to make the next great leap, stuck in a low-energy gear for 1 billion years? This is the era when we were born. Not as humans, not as animals, but as eukaryotes. The first cell with a nucleus. This revolutionary new life form, your distant ancestor, appeared on this stage. But it didn't take over. It didn't explode. It just hid. It was a single-celled organism, swimming terrified through the microbial soup, just another tiny, insignificant part of the boring background hum. And yet the boring billion has its own unclassifiable monster. Because during this time, we find a fossil called Grippania spiralis. It's a 2 billion-year-old coiled, ribbon-like fossil, some as large as your hand. It's the first megascopic fossil we know of, visible to the naked eye. And what is it? Its discovery, which predates even the Francevillian flowers, just deepens the mystery. Is it a coiled-up tube of bacteria? Is it a giant, single-celled amoeba? Is it a simple strand of algae? We have no idea. It's another Francevillian-style enigma, a weirdo from a time that isn't supposed to have weirdos. For 1 billion years, this is the status quo. The rusting ocean, the slimy mats, the single-celled eukaryotes hiding in the soup. What finally broke the spell? What ended the boring billion? Chaos. The supercontinent, now reformed as Rodinia, finally began to break apart. This massive tectonic shift set off a chain reaction. The climate was thrown into chaos, and the world froze. This is the snowball Earth hypothesis. Not a gentle ice age, but a deep freeze. A runaway cold snap so severe that ice may have spread from the poles all the way to the equator. The entire planet, for millions of years, was a white marble in space. This deep freeze would have been the ultimate evolutionary filter, killing off all but the hardiest microbes huddled in volcanic vents or in thin, slushy equatorial water. But this great filter was also a great reset. When the volcanoes under the ice finally pumped enough CO2 into the air to trigger a super greenhouse effect, the ice melted. This meltback would have been cataclysmic, churning the oceans, dredging up those billion-year-old locked-away nutrients, and seeding the seas with the ingredients for new life. When the ice finally recedes, you are in a new world. The boring billion is over. The silence is broken. You are now in the Ediacaran. The great thaw is complete. You are now 600 million years in the past. Welcome to the Ediacaran Period. You are floating in a warm, shallow sea. The water is clear. The sky is blue. And the world is silent. Utterly silent. There are no splashes, no clicks of crustaceans, no chirps of fish. This is a world defined by a profound absence. It is a world without predators. There are no hunters here. There are no hiders. There are no chasers, and nothing to be chased. The entire concept of predation has not yet been invented. And because nothing is hunting, nothing has evolved defenses. There are no shells, no spines, no armor, no camouflage. You look down at the seafloor. It's not the mud or shifting sand you're used to. Instead, the entire seafloor, as far as you can see, is carpeted in a thick, cohesive, purple-green microbial mat. It's like a tough, slimy, living shag carpet that covers everything. And growing from this mat is the garden. This is the Ediacaran Biota, the first large, complex, multicellular life on Earth. But these are not animals as we know them. They are not plants. They are something else. Paleontologists, struggling for a term, sometimes call them the quilted kingdom. Let's look at their body plan. They don't have organs. They aren't built of complex tissues, muscles, or nerves. They are built using fractal or quilted construction. Their bodies are made of repeating, stitched together, modular sacs, or fronds. It's like they are inflatable mattresses, complexly stitched to maximize their surface area. And they need that surface area. Because you'll notice something is missing. They have no mouths, no guts, no anuses, no brains. So, how do they live? This is the central mystery of the Ediacaran. The prevailing theory, our mainstream fact for the night, is osmotrophy. They just lay there. They lay on that rich, nutritious purple microbial mat and absorbed nutrients directly through their skin. They were mat suckers, passive, living sponges. But of course, scholars are deeply divided on this. This osmotrophy works for the flat, mattress-like creatures. But what about the ones that stood upright, like leaves, high in the water column, away from the mat? The debate rages. Were they filter feeders, passively catching marine snow, falling organic bits? Or did they host symbiotic algae, like modern coral does, living off the sunlight? We simply don't know. The feel of this world is one of pure passivity. Nothing moves, at least not quickly. Nothing thinks, nothing hunts. It is a silent, alien garden of stationary, leaf-like, disc-like, and mattress-like life forms, all just existing. It's the planet's first failed experiment in complex life. Let's walk through this bizarre, silent garden and meet its most prominent and most baffling residents. You glide over the purple mat, and the first thing you see looks, for all the world, like someone dropped a quilted bathroom mat on the seafloor. This bath mat is one of the most famous residents of the Ediacaran garden. You're looking at Dickinsonia. It's a classic example of this quilted kingdom. It's perfectly flat, oval-shaped, and covered in raised ribs or segments that all run to a central line or furrow. It looks like a fossilized thumbprint. And they are everywhere. Some are tiny, just a few millimeters across. Others, found in the White Sea of Russia, are enormous, up to 4 feet long, a 4-foot quilted living bath mat. For a very long time, we assumed it was like everything else in this garden. Stationary. We thought it just lay on the purple microbial mat, passively sucking up nutrients through its skin. It was a simple quilted mat sucker. But then, we found the tracks. We found fossilized slabs of that microbial mat. And on them, we saw Dickinsonia fossils. But we also saw ghostly impressions of the same fossil, leading up to it. Trace fossils. Dickinsonia could move. This wasn't a fast movement. It was a slow, majestic glide. You're watching one now. It glides across the seafloor for a few feet, its entire body rippling. Then it stops. It sits on a fresh patch of that purple mat and feeds. We know this because it leaves a bare spot, a negative impression, where it has completely absorbed the mat, eating it. Then, its meal finished, it glides on. This was an active grazer, in a world that was supposed to be completely passive. But how it's built is where the real weirdness begins. You look closer at that central line. It's not a perfect mirror. This isn't the bilateral symmetry that we and 99% of all other animals possess. This is something off. The ribs on the left side don't perfectly line up with the ribs on the right side. They are offset, as if one half of the creature has slid down a few centimeters. This is called glide symmetry. It is a body plan that is, as far as we know, completely alien to our modern world. It does not exist today. It was an Ediacaran experiment in how to build a body, and like the quilted construction, it was a failed one. This bizarre, gliding, symmetrically challenged bath mat caused one of the longest and most bitter debates in paleontology. What is it? For decades, the arguments were fierce. Because it was so simple, it could be anything. One camp argued it was a lichen, a symbiotic relationship between a fungus and an alga. Another camp argued it was a giant single-celled organism, a type of amoeba called a xenophyophore, which builds a shell, a test, out of bits of sediment. A third camp argued it was a fungus, a giant, flat mushroom. And the last camp, almost wishfully, argued it was an animal, a primitive one, like a jellyfish or a coral that had flopped over and was crawling on the bottom. For 50 years, the debate was a perfect stalemate. There was no smoking gun to place it in any kingdom. It was just Dickinsonia. Then, in 2018, everything changed. A Russian scientist, Ilya Bobrovsky, was on a desperate expedition to a remote cliffside site in the White Sea. He was dangling 160 feet up on a rope over the freezing ocean, chiseling out Dickinsonia fossils. He found a fossil slab, so perfectly preserved that the Dickinsonia inside it wasn't just an impression. It still had a faint, thin, organic film preserved inside the rock. He and his team took this film back to the lab. They ran it through a mass spectrometer. They were looking for the molecular fossils, the chemical ghosts of the creature. And they found it. The film was packed with molecules of cholesterol. Cholesterol. That waxy fat molecule that your doctor tells you to keep an eye on. Plants don't make cholesterol. Fungi make a different kind. Ergosterol. Lichens don't have it. But cholesterol, that is the defining hallmark of the membranes in the kingdom Animalia. It was the smoking gun. The debate was over. This 558-million-year-old gliding quilted bath mat with its failed symmetry was an animal. This quirky tidbit is, for me, one of the most profound in all of science. As of right now, Dickinsonia is the oldest confirmed animal in the fossil record. It is the oldest, most ancient member of our own kingdom. That strange quilted thing is your great-great-great-great-grandfather. Dickinsonia was flat, a pancake, absorbing its world. But not all the residents of this alien garden stayed on the ground. Nearby, something else is growing. Something that looks disturbingly and impossibly like a tree. Dickinsonia was flat, but as you walk further through this alien garden, you see that not all its residents kept to the ground. You see something that looks impossible. It looks like a small, gnarled tree, maybe a foot or two high, rooted in the purple microbial mat. But this is no plant. This is Nematothalus. As noted in the video, this is the creature best described as a tree made of flesh. It's one of the most bizarre and unnerving of all the Ediacarans. a true chimera of evolutionary ideas. Let's look at its trunk. It has a stem, or stalk, that holds it fast in the seafloor. But as you get closer, you see this trunk is hard. It's calcified. This is a skeleton. 550 million years ago, in a world of soft, quilted bags, Neanderthalus was experimenting with one of the most revolutionary concepts in history: armor. This is one of the very first attempts at a structural, mineralized skeleton that we have ever found. But it's what's on top of this trunk that truly baffles us. It's not leaves. It's a fleshy, bulbous head or canopy. And this canopy, according to some fossil interpretations, is covered in grasping tentacles and rows of spines. This is the problem. Tentacles? Spines? In the peaceful garden of the Ediacaran? This single creature breaks the rules. The entire Ediacaran world, as we understand it, is passive. It's a world of mat-suckers and gentle filter feeders. But tentacles and spines are not passive. They are active. They are for grasping. They are for defense. They are perhaps for hunting. This flesh tree might not have been a tree at all. It might have been a stationary predator, a Venus flytrap of the Proterozoic, waiting for something to drift by. And to make it all infinitely stranger, you look back at that calcified trunk. It's not solid. As the video highlighted, it's perforated with biological windows. These aren't random post-mortem holes. These are structured organic openings, built into its very body plan. And for our quirky tidbit of the night, it's the shapes of these windows that are so baffling. They aren't just simple pores. They are geometric. We have found them in the shape of circles, ovals, hexagons, heptagons, and almost comically, in the shape of hearts and crescent moons. This naturally leads to one of the most wide-open scholarly debates in the field. What on earth were these windows for? Were they brood pouches, holding and then releasing spores or gametes into the water? Did they house symbiotic algae, acting like tiny built-in greenhouses in its stem, gathering sunlight? Or, as the video hinted, was this part of a digestive system? Were they mouths? Or anuses? We simply have no idea. Neanderthalus is a biological ghost. It's a chimera. It has a primitive Ediacaran quilted body, but it's fused with advanced future concepts like a skeleton and grasping tentacles. It's a failed experiment that was perhaps just too far ahead of its time. While this strange tree was experimenting with the armor and hunting, other residents of the garden were taking the quilted body plan to its absolute fractal extreme. While Neanderthalus was experimenting with being a flesh tree, the true masters of the Ediacaran garden were the rangeomorphs, and the most famous of them all is Charnia. Charnia is, in many ways, the fossil that started this entire field of study. Its discovery is a classic story of amateur brilliance versus entrenched dogma. You are now in Charnwood Forest, England, in the year 1957. A 15-year-old schoolboy named Roger Mason is out rock climbing with his friends. He's not a trained paleontologist, but he's a keen observer. He sees an impression in the rock. It looks exactly like a modern sea fern. He knows this is impossible. The rocks he's looking at are pre-Cambrian. This is the 1950s, and the absolute, ironclad, mainstream historical fact of the day is that no complex life existed in the pre-Cambrian. Period. Life everyone knew began with the shells and trilobites of the Cambrian. He showed a rubbing of the fossil to a local university expert, who famously dismissed it out of hand, telling him it was probably just a plant from the Carboniferous period, hundreds of millions of years later, that had somehow gotten pressed into the older rock. Roger Mason, unconvinced but unable to challenge the experts, simply went home. A year later, another team found the same fossil, and this time, the scientific world was forced to listen. The fossil was named Charnia masoni, after the forest and the boy who first found it. It wasn't a fern. It's the classic Ediacaran quilt. You're looking at one now. It's a leaf made of repeating branching fractal quilts. Each branch is a smaller version of the main frond, and each sub-branch is a smaller version of that. It had a small, circular, hold-fast disc at the bottom, which glued it to the seafloor mat. It stood upright, gently waving in the silent current. But how did we know it wasn't a plant or an alga? For decades, that was the assumption. Charnia looked like a plant, so it must be a plant living off sunlight. This is the aha moment, the key piece of scientific evidence. Paleontologists began finding Charnia fossils elsewhere in the world. Specifically, they found them in rocks in Newfoundland. Rocks that were unquestionably formed in the abyssal plain, the deep, deep ocean, thousands of feet down. They were miles below any level that a single photon of sunlight could ever reach. This was the smoking gun. It could not be a plant. It was not photosynthesizing. This proves it was a heterotroph. It ate food. It was a filter feeder. You're watching it now. It stands tall in the dark, using its huge fractal leaf not to catch sun, but to act as a net. It is passively catching marine snow, the constant gentle rain of organic detritus, dead microbes, bits of mat, falling from the rich waters above. This fractal, quilted body plan, our quirky tidbit for the night, is an incredibly efficient design for this lifestyle. It maximizes surface area for absorbing or catching food, while minimizing the biological cost of building it. It's a low-energy solution for a low-energy passive world. This body plan, the rangeomorphs, was wildly successful. For over 30 million years, these fractal leaves were the dominant life form on the planet. They filled the oceans, from the sunlit shallows to the abyssal dark. And then, they all vanished. Completely. As the video noted, they are a true evolutionary dead end. This entire successful fractal kingdom left 0 living descendants. They were a failed experiment. The alien garden was beautiful, silent, and doomed. And the reason it was doomed, the reason this failed experiment came to a crashing end, may be because of a new, terrifying innovation, represented by one of its smallest but most sinister residents. You're kneeling on the seafloor, looking closely at that purple microbial mat. Among the passive, leaf-like fronds of Charnia, you suddenly see scratches. These aren't random marks. They are long, deliberate, fan-shaped grazing marks, as if a tiny rake has been dragged across the mat. This is a famous trace fossil, a ghost of an action, known as helminthoidichnitis. For decades, we found these scratches all over the world, but we had no idea what was making them. Then, at a fossil site in Australia, we found the culprit. At the start of one of these fan-shaped tracks, we found the fossil of the creature that died while making it. You're looking at it now. Its name is Kimberella. And it looks modern. This is not a quilted mattress like Dickinsonia. It's not a fractal leaf like Charnia. It's a complex, teardrop-shaped, slug-like creature, about the size of your thumb. It has a frill running around its edge, which it probably used to ripple through the water, just like a modern snail or sea slug. It has a distinct front and a distinct back. It has bilateral symmetry, just like you. This is the game changer. We know exactly how it made those marks. Scientific evidence from beautifully preserved fossils shows that Kimberella had a proboscis. This was a retractable snout or feeding tube that it would extend from its front end. It would use this proboscis to graze on the nutritious microbial mat, scraping up food as it went. This is not a passive, mat-sucking absorber. This is an active feeder. It is moving with purpose. It is hunting for its food. It has a mouth, a gut to process that food, and presumably an anus to excrete the waste. It is, in all likelihood, a very primitive, very early mollusk, an ancestor of today's snails and clams. This is the creature that may have ended the Ediacaran. This is the scholarly debate that rages today. Was the invention of active feeding and movement the gunshot that brought the peaceful garden crashing down? Imagine this world. For 30 million years, life was a stationary, passive, quilted buffet. And then Kimberella evolved. A creature that could move and eat the mat, and perhaps eat the other Ediacarans. This new high-energy lifestyle would have been a catastrophe for the slow, passive, quilted kingdom. Kimberella was, in essence, the wolf in the garden of sheep. And for our quirky tidbit, we have evidence that Kimberella knew it was in a dangerous new world. Some fossils suggest it had a hard shell, a scleret on its back, like a primitive snail. Why? Why would a creature evolve a defensive shell in a peaceful world with no predators? The implication is chilling. Kimberella may have been a grazer, but its very existence implies that something else, perhaps an unknown, soft-bodied predator, or even other Kimberella, had just invented hunting. Kimberella's shell is the first faint hint of a terrifying new pressure. The invention of eating leads directly and inevitably to the invention of being eaten. This is the starting gun. The evolutionary arms race of defense and attack is about to begin. The silent alien garden of the Ediacaran is about to be violently torn apart and replaced by the Cambrian Explosion. You are now 541 million years in the past. The 30 million year long silent reign of the alien garden is over. In the blink of a geological eye, a time span of just 10 to 20 million years, the entire planet changes. The world fills with animals. This is the Cambrian Explosion. And the first thing you notice is the armor. The soft, quilted, passive creatures of the Ediacaran are gone, vanished. They are replaced by defenses. You see shells, spikes, plates, hardened carapaces. This is the invention of the skeleton, not just as a support, like in Neanderthals, but as armor. The seafloor itself is transformed. The thick, purple microbial mats that carpeted the world are gone. They have been eaten into oblivion by grazers like Kimberella and burrowed through by a billion new worm-like animals. This is the Cambrian substrate revolution. The seafloor is no longer a mat. It's just mud and sand, churned up by the new, frantic, burrowing, hiding, and hunting lifestyles. What caused this? What was the trigger? for this sudden, violent explosion of complex, armored life. This is one of the most significant scholarly debates in all of science. Hypothesis 1. The oxygen trigger. This is the classic mainstream theory. A new, sudden pulse of oxygen flooded the atmosphere and oceans. For the first time, there was enough fuel to power high-energy lifestyles. Moving, hunting, digesting, and, most importantly, the biologically expensive process of growing a hard, mineralized shell. All of it finally became possible. The oxygen ceiling was broken. Hypothesis 2. The snowball Earth reset. Remember that global deep freeze that ended the boring billion? This theory argues that the filter of the snowball Earth extinctions cleared the slate, wiping out the old, stagnant microbial ecosystems and opening up a billion new evolutionary job opportunities. The explosion was just life rushing to fill that vacuum. Hypothesis 3. The predation arms race. This is the most dramatic theory. It argues that the trigger wasn't environmental, it was biological. The invention of predation by a creature like Kimberella, or something we haven't found yet, was the real starting gun. The moment one animal evolved to eat another, it forced an arms race. You either evolved armor, evolved to burrow, evolved to run, or you died. The explosion, this theory argues, was a war. And the fossils we see are the weaponry. Whatever the cause, the result is staggering. This is the mainstream historical fact of the Cambrian. In this one brief window of time, every single major animal, body plan, or phylum that exists today appears all at once. You see the first arthropods, ancestors of insects, crabs, and spiders. You see the first mollusks, ancestors of snails and squid. You see the first chordates, our own deep, deep ancestors. They all explode onto the scene, fully formed. It's as if the blueprints for all modern life were drawn up in a single, frenzied burst of creation. And for our quirky tidbit, you also see a lot of phyla that didn't make it. Blueprints that evolution drew up and then threw away. Weird wonders. Failed experiments. Creatures so bizarre, so alien in their construction, that we still cannot classify them. They don't fit in any modern phylum. To find these weird wonders, we must journey to one of the most famous fossil beds on Earth. A specific small quarry of shale high in the Canadian Rocky Mountains. You are now in the Burgess Shale. Let's meet its most famously misunderstood resident. You're now kneeling in the mud of the Burgess Shale, 508 million years ago. You're looking for the weird wonders. You see a tiny worm-like fossil, just an inch or two long. This is Hallucigenia. And it is, without a doubt, the most famously misunderstood fossil of all time. When the British paleontologist Simon Conway Morris first described this creature in the 1970s, it was so bizarre, so utterly alien, that he was left wandering in mind. The fossil was just a smear of a spiky worm. He had to guess how it was oriented. And he guessed spectacularly wrong. His 1970s reconstruction, which became the mainstream historical fact for decades, is a masterpiece of confusion. He thought the creature walked on its 7 pairs of long, stiff, stilt-like spines. He imagined it teetering across the seafloor on these inflexible stilts. He couldn't figure out what the other set of appendages, the tentacles on its back, were for. He guessed they were feeding tubes, maybe catching bits of food from the water. It was a creature that walked on spikes and ate with its back tentacles. It was so absurd, so nonsensical, that he named it Hallucigenia, for the hallucinatory nature of the beast. It was completely 100% wrong, and it stayed wrong for 20 years. Then, in the 1990s, new fossils were found in China. They were perfectly preserved, and we got the scientific evidence that flipped the animal. Paleontologists looked at the tentacles with an electron microscope, and they found claws, tiny little hooked fingernails at the end of each one. These weren't feeding tubes, they were legs. This meant the stilts weren't legs, they were spines, and they were on its back. The entire animal was upside down. The stilts it was walking on were actually a formidable set of defensive spines, just like a porcupine's. The feeding tentacles on its back were actually its legs, which it used to tiptoe on the seafloor. But this just solved one mystery. It immediately created a new one. This is the scholarly debate that took another 20 years to solve. Which end is the head? We could not tell. Both ends of the worm looked almost identical. For decades, we were looking at it backwards. The head was assumed to be the blob-like stain at one end, which some interpreted as a simple head. The tail was the other end. Finally, in 2015, scientists from the University of Cambridge put the blob end under an even more powerful electron microscope. They digitally peeled back the layers of the fossil, and underneath, they found it. A simple pair of eyes. And just below them, a ring of simple teeth inside its throat. It was the head. For our quirky tidbit, these legs and that head connect Hallucigenia to a modern and equally weird group of animals, the Onychophora, or velvet worms. These are strange worm-like creatures with stubby legs that live in the jungles of the southern hemisphere today, and they hunt by shooting a paralyzing goo or slime at their prey from two nozzles on their face. Hallucigenia is their 500-million-year-old granduncle. We had finally solved the riddle. We knew what it was, which way was up, and which way was forward. And we knew why it was built the way it was. Those long, sharp, backward-curving spines on its back, they were clearly for defense. Defense against what? Well, you might have just felt a shadow pass overhead. A big shadow. Those formidable backward-raking spines on Hallucigenia were a brilliant defense. But the fact that they needed to exist tells you everything you need to know about this new Cambrian world. They were a response to a new and terrifying pressure. You're about to meet that pressure. As you scan the murky water just above the seafloor, you see it. It's about 4 inches long, swimming awkwardly with flaps along its side. This is Opabinia, and Opabinia is, quite possibly, the single weirdest wonder to ever come out of the Burgess Shale. It is the poster child for the failed experiment. For our quirky tidbit tonight, let's go back to the 1970s. The paleontologist Harry Whittington, the same man who would later help assemble Anomalocaris, has been painstakingly reconstructing Opabinia from the flattened shale fossils. He is finally ready to present his findings to a packed, serious scientific meeting. He puts the final reconstruction up on the projector screen. The room laughed. The assembled serious academics laughed out loud. They thought he was joking. They thought it was a prank. The creature he was proposing was so utterly, biologically absurd that it looked more like a surrealist's doodle than a real living animal. But it was real. You're looking at it now. Let's do the features checklist, because it's a wild ride. First, the eyes. It doesn't have 2. It has 5. 5 stalked mushroom-like eyes sit on its head, 2 pointing left, 2 pointing right, and 1 right in the middle, pointing forward. It had 360-degree vision. Second, the mouth. You look for it on the front. It's not there. Its mouth is underneath its body, and it faces backwards. Third, the face. Sticking out of the front of its head is a long, flexible hose-like proboscis. It looks exactly like the nozzle of a vacuum cleaner. It's about 1/3 of the creature's entire body length, and on the very end of this hose is a spiked, grasping claw. Now let's put this all together. This is the scientific evidence from the fossils. A 5-eyed blob with side flaps, a backward-facing mouth, and a long hose claw on its face. How did it live? You're watching its hunting strategy right now. It swims awkwardly, hovering just above the seafloor. Its 5 stalked eyes are scanning in all directions, a perfect early warning system and hunting scope. It spots a small, soft-bodied worm, perhaps a relative of Hallucigenia that didn't have spines. It hovers. It lowers that vacuum hose claw, snatches the worm, and then comes the party trick. It curls the hose backwards, underneath its own body, and stuffs the worm into its backward-facing mouth. This is a body plan so convoluted, so jury-rigged, that it's a miracle it worked at all. And this, of course, leads to the great scholarly debate. Where does this thing fit in the tree of life? The short answer is, it doesn't. Opabinia is so weird, it was put in its own phylum. It's a stem arthropod. That's a polite way of saying it's related to the arthropods, insects, crabs. But it's not one of them. It's an almost arthropod, a cousin from a branch of the family tree that was so early it was testing out ideas. Like 5 eyes and hose claws, before the official arthropod body plan, jointed legs, 2 eyes, was finalized. Hallucigenia, with its spines, and Opabinia, with its hose claw, were both weird wonders. They were both prey, in their own way. It's time to meet the predator. The creature that all the other Cambrian animals, from the spiky worms to the hard-shelled trilobites, were evolving to escape. The spines of Hallucigenia and the 5 eyes of Opabinia were defenses against a creature so large and so terrifying that for over 100 years, we didn't even know it existed. This is perhaps the greatest detective story in the history of paleontology. We are still in the Burgess Shale, but we are not looking for one creature. We are looking for 3. For over a century, scientists digging in these rocks kept finding 3 very different and very confusing fossils. The first fossil was a pair of large, spiky, jointed appendages. They were clearly limbs of some kind. They looked, for all the world, like the tail end of a shrimp. They were common. Scientists didn't know what shrimp they belonged to, but they were so abnormal-looking that they gave them a name. Anomalocaris, which means simply abnormal shrimp. That was creature number 1. The second fossil was a strange, circular, flattened disc. It was ringed with sharp, overlapping plates, and it had a hole in the middle. It looked exactly like a pineapple ring. Scientists looked at this and thought it was a type of jellyfish. They gave it its own name, Pikaia. That was creature number 2. The third fossil was a large, spongy, segmented blob. It was clearly a body of some kind, with flaps along the side for swimming. But it had no head, no mouth, no appendages. It was just a body. Scientists guessed it was a type of sea cucumber or perhaps a sponge. They gave it its own name, Lagania. That was creature number 3. So for 100 years, the ecosystem of the Burgess Shale was understood to have these 3 animals in it. 1. An abnormal shrimp, Anomalocaris. 2. A pineapple ring jellyfish, Pikaia. 3. A headless sponge blob, Lagania. This was the mainstream historical fact, and it was completely wrong. The aha moment, the mainstream fact that shattered this, didn't come until the 1980s. A team of paleontologists at Cambridge, led by a Harry Whittington, the same man who had been laughed at for Opabinia, was cleaning a new large fossil slab from the quarry. They were carefully chipping away the rock, and they found the shrimp tail, Anomalocaris, and attached to the shrimp tail, they found the pineapple ring jellyfish, Pikaia. It wasn't 2 animals, it was 1 animal. The shrimp tail wasn't a tail at all. It was a feeding appendage. And the jellyfish wasn't a jellyfish. It was a mouth. Suddenly, the mystery snapped into focus. All 3 animals were 1. The abnormal shrimp, Anomalocaris, was the pair of feeding arms. The pineapple ring jellyfish, Pikaia, was the circular toothed mouth. And the headless sponge, Lagania, was the body that these parts attached to. The scientists had, over 100 years, found the arms, the mouth, and the body of the same animal, and had classified them all as separate species. It was like finding a fossil of a human arm and calling it arm icus, finding a human jawbone and calling it tooth is, and finding a human torso and calling it body us, and never realizing they all went together. The abnormal shrimp, Anomalocaris, was the name that stuck, and the reassembled creature was a monster. This was not a small, inch-long worm. Anomalocaris was 3 feet long. In the Cambrian, a world where everything else was thumb-sized or hand-sized, this was a leviathan. It was the T-Rex of its day. You're looking at the assembled predator now. It has the 2 large, spiked, great appendages, Anomalocaris, on the front of its face. It has the circular pineapple ring mouth, Pikaia, underneath its head. And its body, Lagania, is a streamlined, swimming chassis with powerful fins undulating down its sides. We had finally, after a century of confusion, assembled the monster. Now scientists had to figure out, how did it live? And what was it doing with those super eyes and that pineapple mouth? This was the king of the Cambrian. You're watching it hunt. Anomalocaris was the T-Rex of its day, an apex predator in every sense of the word. At 3 feet long, it was a leviathan in a world of minnows, and it sat at the absolute top of the food chain. And it was a visual hunter. This is the key scientific evidence that changed everything. For a long time, we thought of the Cambrian as a murky world, where animals sensed each other through touch or smell. Chemoreception. Anomalocaris proved that wrong. In 2011, scientists found a pair of fossilized Anomalocaris eyes. They were massive. They were stalked, sticking off the head on 2 stems, giving it a wide field of vision. And most importantly, they were compound eyes, just like a modern fly's. And compound is an understatement. The 2011 study, using advanced imaging, estimated that each eye had 30,000 lenses. For our quirky tidbit tonight, let's put that in perspective. The housefly, a famously sharp-eyed insect, has about 6,000 lenses. The dragonfly, one of the most effective aerial predators on Earth today, has about 28,000 lenses. This 508 million-year-old abnormal shrimp had better vision, or at least more complex vision, than a modern dragonfly. This thing could see. You're watching its hunting strategy now. It flies through the water, not like a fish, but by undulating those fins on its sides in a wave motion, like a cuttlefish. It's a fast, agile, and silent swimmer. Its two super eyes are scanning the seafloor below. It spots its prey. A trilobite, one of the other armored creatures of the Cambrian, is scuttling across the mud. Anomalocaris locks on. It rockets forward, a burst of speed. It swoops down. Its two large, spiky great appendages, the shrimp tails we found, reach out, caging the trilobite. And then, what happens next? This is the new scholarly debate that rages about the king. For years, the pineapple ring mouth, Pikaia, was assumed to be a crunching device. We had found thousands of fossilized trilobites with bite marks in them. Specifically, W-shaped bites, or cracks in their hard shells. It all seemed to fit. Anomalocaris crunched trilobites with its pineapple mouth. But there's a problem. A big one. Recent biomechanical studies of the pineapple ring mouth show that it was not hard in the way our teeth are hard. It wasn't calcified, it was soft, like hard cartilage. Think of your ear. It simply could not have crunched through a hard, mineralized trilobite shell. It wasn't strong enough. It would have broken itself. So, if it wasn't crunching trilobites, what was it doing? And who was biting all those trilobites? This has led to a fascinating new theory. Anomalocaris may have been a sucker, not a cruncher. In this new scenario, it does grab the trilobite with its two great appendages, but it doesn't try to bite it. It uses those spiky, powerful arms to bend the trilobite, to crack its shell, or to articulate it, pull it apart, at its segments. Then, once it has cracked the armor, it brings the pineapple mouth in, and it uses it like a suction cup. It latches on to the crack and sucks out the soft insides. It's a vampire of the Cambrian, or perhaps just a slurpy specialist. This also explains why it would have hunted soft-bodied prey like Hallucigenia just as often. The pineapple mouth would have been perfect for sucking up a soft, squishy worm. Anomalocaris was the king, the super predator born of the Cambrian arms race. It was the weird wonder that won. But while Anomalocaris was the clear king of the weird, another fossil from the Burgess Shale presents a completely different and perhaps deeper kind of problem. This next creature, it doesn't look that weird. In fact, it looks familiar. And that's the problem. It's impossible. Anomalocaris was a weird wonder that became a king. But our next creature from the Burgess Shale is a completely different kind of mystery. It doesn't look as bizarre as Opabinia or Hallucigenia. In fact, it looks alarmingly familiar. And that is the problem. This creature shouldn't exist. It's a time traveler that breaks the timeline of evolution. You're looking at Nectocaris. Its story begins not with a bang, but with a whimper. In 1910, a single terrible fossil of this creature was found in the Burgess Shale. It was badly preserved, flattened, and incomplete. It looked, as the video noted, like a stretched-out shrimp. It seemed to have some fins and maybe some arms. It was a puzzle. Scientists, as per the mainstream fact of the 20th century, classified it as a weird arthropod, or maybe a primitive chordate. Our phylum. It was a minor mystery, a C-list celebrity in the Burgess Shale Zoo, and as the video transcript states, it was essentially buried and forgotten about. It remained forgotten for 100 years. Then, in 2010, a new expedition to the Burgess Shale uncovered 91 new specimens of Nectocaris. And these weren't bad fossils. They were perfect. They were pristine. And they revealed that the shrimp classification wasn't just wrong, it was comically wrong. The new animal, revealed in all its glory, was not a shrimp. It was a squid. Or at least it looked exactly like one. This is the scientific evidence from these new fossils. The creature, about 2 inches long, had a kite-shaped body, just like a modern squid. It had 2 large stalked eyes. It had 2 tentacles. Not the 8 or 10 of modern squid, but 2. And most shockingly, it had a large funnel on its underside. This is the jet propulsion system that defines a cephalopod, the squid and octopus family. It sucks water in and blasts it out the funnel to jet backward. This was a Cambrian-era, jet-propelled predator. This is the impossible problem. Nectocaris is from the Middle Cambrian, 508 million years ago. The first accepted cephalopods in the fossil record, creatures with hard shells, like the cone-shelled nautiloids, don't appear until the next geological period, the Ordovician. They are 30 to 40 million years younger than Nectocaris. This is a profound, timeline-shattering paradox. To quote the video's excellent analogy, this is exactly like a paleontologist finding an animal resembling a modern human before any of the most primitive primates had even appeared. It breaks the known, accepted A then B then C timeline of cephalopod evolution. This has naturally ignited a furious scholarly debate that is still unresolved. Hypothesis 1. The timeline is wrong. Nectocaris is the first cephalopod. Our timeline is just wrong. This would mean that the entire 30 million year early history of cephalopods is a ghost lineage. We are missing 30 million years of their fossils, and Nectocaris is the only one we've found. Hypothesis 2. It's a fake. It is not a cephalopod. It's a convergent evolution experiment. This theory argues that Nectocaris is from a completely different, unrelated phylum that has evolved to look like a squid. It invented jet propulsion, tentacles, and big eyes all on its own, and then went extinct, leaving the real cephalopods to invent it all again, 30 million years later. So, where does that leave Nectocaris? For our quirky tidbit, as the video notes, it's now homeless. It's been placed in its own controversial homeless family called the Nectocaridae. It is a fossil without a phylum, a creature without a country, a time-traveling squid shrimp that breaks all the rules. While this impossible cephalopod was jetting around the Cambrian seas and Anomalocaris was slurping trilobites, another much humbler creature was swimming nearby. It was tiny. It was defenseless. It didn't look like much at all, but it would be the one to survive. While the time-traveling Nectocaris presents a paradox, and the king, Anomalocaris, rules the sea, you're looking at another creature. But you'll probably miss it. It's tiny, maybe 2 inches long, ribbon-like, and swimming with a weak side-to-side S motion. It looks like a simple worm. This is Pikaia. It is, without a doubt, the least impressive animal we've seen so far. It has no quilted body. It has no fractal fronds. It has no spines. It has no 5 eyes. It has no hose claw. It has no great appendages, no pineapple mouth, and no jet propulsion funnel. It is a small, soft, defenseless 2-inch worm. It is insignificant. But you look closer. You zoom in on this tiny, ribbon-like creature, and you see something. Running down the inside of its back is a stiff, flexible, longitudinal rod. This is a notochord. That single, simple, anatomical feature is one of the most important in the history of life. A notochord is a precursor to a vertebral column, a backbone. This is the mainstream historical fact of the night. Pikaia is not a worm. It's not an arthropod. It is a chordate. It is a member of the same phylum as you. This small, insignificant 2-inch worm is one of our oldest known relatives in the entire fossil record. It is not our direct ancestor, but it's an early cousin. You are, for the first time in this journey, looking at family. What was its lifestyle? It was prey. You're watching it now. It's a bottom feeder, swimming just above the seafloor, filter feeding. It's sucking in water, filtering out tiny food particles and squirting the water back out. It is hiding. It is spending its entire life trying to avoid the super eyes of Anomalocaris. It is hoping it doesn't get sucked up by the hose claw of Opabinia. It is the loser of the Cambrian. And this is the beautiful, profound, and baffling twist of evolution. Let's pull back and look at the whole play of the Cambrian 508 million years ago. The star of the show, the king, is Anomalocaris, the 3-foot-long, supersighted T-Rex of its day. The bizarre sidekicks are the failed experiments, the 5-eyed Opabinia and the spiked worm Hallucigenia. The impossible paradox is the time-traveling squid, Nectocaris, and the insignificant worm hiding in the mud. The extra with no lines is Pikaia. Now let's fast forward 500 million years. The king, Anomalocaris, extinct, left 0 descendants. The failed experiments, Opabinia and Hallucigenia, extinct, left 0 descendants. The impossible paradox, Nectocaris, extinct, left 0 descendants. And the insignificant worm, the loser, the one that won the Cambrian lottery purely by not losing, its descendants survived. This is our quirky tidbit, and it's a big one. The fact that this one, tiny, defenseless, worm-like chordate survived the great filter of the Cambrian, while all the gods and kings like Anomalocaris went extinct, is the only reason vertebrates exist at all. That notochord eventually evolved into a backbone. That backbone gave rise to fish. Those fish evolved jaws. Those jawed fish, like Dunkleosteus, conquered the seas. One of those fish crawled onto land, evolving legs. Those legs gave rise to amphibians. Those amphibians gave rise to reptiles. Those reptiles gave rise to dinosaurs and to mammals. And one of those mammals is you. Your entire existence, the invention of fish, reptiles, dinosaurs, and humans, is a happy accident, all because a 2-inch worm was really good at hiding. The Cambrian world, with its weird wonders and terror predators, couldn't last forever. Most of these blueprints, these failed experiments, would soon vanish. The tree of life was about to be pruned, but the problem of unclassifiable creatures, the WTF fossils, didn't end with the Cambrian. We just have to jump forward 200 million years to a muddy tropical swamp in what will one day be Illinois. The explosive, chaotic, anything-goes world of the Cambrian didn't last. The explosion didn't end with a bang. There was no single asteroid or supervolcano. It ended with a fizzle. A series of small, pulsing extinction events at the end of the Cambrian period and into the next period, the Ordovician, pruned the tree of life. And in this great pruning, there was a very clear pattern. The losers were the weird wonders, the failed experiments. Opabinia, with its 5 eyes and hose claw, gone. Anomalocaris, the 3-foot-long king with super eyes, gone. The entire phylum of spiked worms like Hallucigenia, gone. Nectocaris, the time-traveling squid, gone. Almost all of those bizarre stem phyla, the almost arthropods and almost mollusks that represented the first drafts of life, were evolutionary dead ends. The blueprints were torn up and thrown away. The winners were the boring phyla. The survivors were 1. The arthropods, specifically, the trilobites, which would rule the seas for the next 250 million years. 2. The mollusks, the real ones, the shelled ancestors of snails and nautiloids. 3. The brachiopods, lamp shells, that looked like clams, but weren't. 4. And the chordates. Our hiding, insignificant worm-like ancestor, Pikaia, survived the pruning. The foundations of the modern animal world were now set. The weirdness was, for the most part, filtered out of the system. What followed this pruning was not another explosion of new phyla. It was the Great Ordovician biodiversification event. This was Explosion 2.0. Life was no longer inventing new body plans. It was now innovating and diversifying within the winning body plans. The winners of the Cambrian lottery now had an empty world to fill, and they exploded in diversity, creating thousands of new species of trilobites, mollusks, and, for the first time, fish. This, of course, leads to one of the deepest and most philosophical scholarly debates in all of paleontology. Why did our phyla win? Were we just luckier? Was it a contingency, as the famous paleontologist Stephen Jay Gould argued? Was Pikaia's survival just a dumb luck accident? If you rewound the tape of life and ran the Cambrian explosion again, would a different worm survive? Would the world today be inherited by the 5-eyed descendants of Opabinia? Or was our body plan just better? Was the jointed exoskeleton of the arthropods a superior design? Was the notochord of the chordates a more adaptable blueprint than the quilted body of Dickinsonia or the hose claw of Opabinia? We don't know. And we can't know. We are the winners, writing the history. The world had seemingly simplified. It had settled down, choosing the boring phyla we still know today. The age of unclassifiable monsters was over. Was it? Did the weirdness really go away, or did it just go into hiding? To find out, we must jump forward 200 million years. The age of fish has come and gone. The first forests are growing on land. We are now in the Carboniferous Period, in a hot, muddy, tropical swamp, in a place that will one day be Illinois. And unclassifiable weirdness is thriving. You are now 309 million years in the past, deep in the Carboniferous Period. But you are not in the ocean. You are standing in a hot, humid, fetid, tropical swamp. This is a vast river delta, choked with 100-foot-tall club moss trees and giant ferns. This sweltering, muddy landscape will one day be buried, compressed, and turned into the coal seams of Illinois. And it's here that we find one of the most remarkable fossil traps on Earth, the Mazon Creek Formation. Here's how this trap works. When an animal in this muddy delta, a shrimp, a fern, a fish, or just a weird blob, dies, it sinks into the soft, oxygen-poor mud. This mud is incredibly rich in a specific mineral, siderite, or iron carbonate. Almost immediately, this iron mineral begins to precipitate out of the water, forming a hard, rocky crust around the dead animal. This crust grows fast. It forms a hard, dense, ironstone concretion, or nodule, around the soft body, before it can decay. This nodule is a perfect prison. It's a snapshot in rock. This is a type of fossil bed called a Lagerstätte, a storage place. And it's famous because it doesn't just preserve hard parts like bones and shells. It preserves the 99% of life that is soft. It preserves eyeballs, guts, fins, tentacles, worms, all the squishy things that, under normal conditions, would rot away in hours. This is our mainstream historical fact. The Mazon Creek Lagerstätte is one of the most important windows we have into the full picture of life. It shows us what the squishy 99% of the ecosystem looked like. But this perfect prison creates a perfect problem. Because it preserves so many soft, blob-like creatures that have no modern equivalent, Mazon Creek is also home to some of the most problematic, unclassifiable, and WTF fossils ever found. And for our quirky tidbit, finding them is a treasure hunt. The fossils are hidden. They just look like rocks. Collectors walk the spoil heaps of the old Illinois coal mines, picking up these oval-shaped, rust-colored, ironstone nodules. You can't just chisel them open. The only way to see the fossil inside is to take the nodule home, put it in a bucket of water, and freeze and thaw it, over and over, for months, or even years, until one day, pop! The rock geode splits perfectly in half along the seam of the fossil, revealing the 300-million-year-old ghost trapped inside. And in 1958, an amateur collector named Francis Tully popped open a nodule and found a monster. This nodule-popping hobby is what led, in 1958, to one of the most famous discoveries in American paleontological history. An amateur collector named Francis Tully was out hunting. He popped open an ironstone nodule, and he just stared at it. He had found a thing. A monster. He had no idea what it was. It looked like nothing he had ever seen. He took it to the experts, the paleontologists at the Field Museum of Natural History in Chicago. And they were stumped. These were the world's leading authorities on fossils, and they were, to quote the video, absolutely perplexed. They had never seen anything like it. They couldn't classify it. They couldn't even guess. They gave up, and in a moment of academic humility, they simply nicknamed it Mr. Tully's Monster. The name stuck. Today, it is known officially as Tully Monstrum gregarium, and it is, as our mainstream fact of the night, the official state fossil of Illinois. Which is wonderfully ironic, because nobody knows what it is. It is the ultimate problematic fossil. Let's look at it. You're holding one of these nodule halves in your hand now. The monster inside is a chimera. It's a biological house of spare parts. The body. First, you have a soft, cigar-shaped, segmented body. This suggests a primitive creature, like a worm or an early arthropod. The tail. At the back, it has a triangular fin, like a fish or a squid. The eyes. This is where it gets weird. Sticking horizontally out of the middle of its body is a rigid bar, and at the ends of this bar are its two stalked eyes. It's a hammerhead, but the hammer is a separate stalk coming out of its body, and its eyes are on the ends of that. The mouth. And then there's the front. Sticking out of its head is a long, jointed, trunk-like proboscis. It's as long as its entire body. And at the very end of this elephant trunk is a claw-like mouth, complete with two jaws and tiny, sharp teeth. Now, you try to pin the phylum on this thing. Imagine the scientists playing this game. It's segmented. It's a worm, but it has a fin and complex stalked eyes. Okay, it's an arthropod, like Opabinia, but its body isn't jointed and it has no legs. Okay, it's a mollusk, a free-swimming sea slug. But no mollusk has this body plan, and that claw mouth. Okay, it's a conodont, a jawless eel-like vertebrate. But where is its backbone? Where is its notochord? This is the Tully Monster problem. It's an everything animal. It has features from 4 different phyla. It fits nowhere. And for our quirky tidbit, this isn't a one-off mystery like Opabinia. This isn't a rare fossil. It's so common in the Mazon Creek nodules that amateur collectors find thousands of them. We have a massive, statistically significant collection of an animal that we cannot classify. For 50 years, this was the funnest mystery in paleontology. Tully Monstrum was the unclassifiable monster that everyone loved because it was unclassifiable. And then, in 2016, a team of scientists from Yale dropped a bombshell in the journal Nature. They claimed they had solved it. That 2016 Nature paper was the bombshell. A team led by Victoria McCoy at Yale University announced that the mystery was over. They had used a scanning electron microscope, SEM, on over 1,200 different Tully monster fossils, and they had found the smoking guns. This new, high-powered scientific evidence seemed to solve everything. First, they re-examined that faint white line running through the creature's body. For decades, it was assumed to be a gut trace. The Yale team argued it was not a gut. It was a notochord, the stiff, flexible rod that defines a chordate, the pre-backbone we saw in Pikaia. Second, they identified paired repeating structures in the head region as primitive gill pouches, just like in a larval fish. Third, they argued the segments on the body were not segmentation, like in a worm, but myomeres, the W-shaped muscle blocks you see in a modern fish fillet. And fourth, the clincher, the eyes. They used the SEM on the pigment inside the fossilized eye stalks. They found melanosomes, pigment cells, and they argued that the shape, size, and layering of these melanosomes were identical to those found in a vertebrate eye and structurally different from those in an invertebrate eye, like a squid's. The verdict was in. The Tully Monster was a vertebrate. It was a stem vertebrate, a type of jawless fish, a bizarre relative of the modern lamprey. The mystery was solved. The news went global. Illinois's state fossil finally had a family. It was a vertebrate, just like us. For 1 year. In 2017, the scholarly debate erupted into an open Tully war. A new team of scientists published a rebuttal in the same journal, Nature. They had re-examined all of the 2016 team's smoking gun evidence, and they refuted it, point by point. That notochord, they argued it was just a gut trace. The way it was preserved was, in fact, identical to how guts are preserved in other Mazon Creek fossils, like shrimp and worms. Those gills, they argued they were not gills, but just muscle bands in the body wall, or perhaps part of the complex muscle system used to retract that giant proboscis. And the eyes, the real smoking gun? The rebuttal team argued that the chemistry and structure of those melanosomes were also perfectly consistent with the eye of a cephalopod, a mollusk, like a squid or octopus. They argued the 2016 team had jumped the gun, seeing a vertebrate pattern where one didn't necessarily exist. And just like that, poof, the solution was gone. The Tully War was on, and it is still raging today. Every few years, a new paper comes out proving one side, and another paper comes out disproving it. As of right now, we are back to square one. The vertebrate theory, which seemed so solid, is in deep, deep doubt. The Tully Monster is, once again, an unclassifiable enigma. For our quirky tidbit, Tully Monstrum is the perfect frustrating example of how more evidence, like a fancy new electron microscope, doesn't always solve a fossil mystery. Sometimes it just gives the scientists more things to fight about. The Tully Monster may be the star weirdo of the Mazon Creek swamp, but it is not the only one. The swamp was also home to a few creatures so simple and so weird they were just given letters. Meet the alphabet animals. The Tully Monster may be the star weirdo of the Mazon Creek swamp, but this 300-million-year-old Lagerstätte was a factory for producing biological puzzles. As you sift through the ironstone nodules, you find other creatures so simple, so baffling, and so lacking in modern comparison that scientists, in their frustration, just gave up and nicknamed them the alphabet animals. The first one you find is known as the H animal, or Adakistus. You pop the nodule, and it's not an animal in any sense you recognize. It's a shape. It is literally shaped like a capital letter H. It has 2 vertical arms and 2 vertical legs, all connected by a horizontal crossbar. It's a 3D stick figure, drawn in the mud. What is this? The scholarly debate here is just a collective shrug. The video transcript suggests the best guess is that it was a colonial animal, like a very, very simple coral, that just grew in this shape for some reason. Maybe this H shape was the most efficient to filter feed in the muddy swamp water. But for our quirky tidbit, it gets even stranger. As the video notes, many Adakistus fossils have a weird growth in the middle of the crossbar. A lump. And this lump isn't a random blob. It has distinct repeating shapes. Sometimes it's a perfect circle. Other times, it's a heart. We have no idea what this was. A reproductive organ, a brood pouch, a float to help it drift, a communal stomach for the colony. It's an H-shaped thing with a heart-shaped lump. It's a problem fossil. But the real scientific problem, the true alphabet animal that breaks biology, is its neighbor, the Y animal, or Echinacea. You pop another nodule. This one looks familiar, even. It looks like a sea anemone. It's a small Y-shaped creature. It has a stalk, the base of the Y, that was probably stuck in the mud, and the top of the Y branches into two arms, which were likely covered in tentacles for catching food. It's a cnidarian, a primitive radially symmetrical animal, like a jellyfish or a coral. Case closed, until you look closer. Way closer. The perfectly preserved soft tissue in the nodule reveals impossible features. 1. Symmetry. It doesn't have radial symmetry like a pie, where all slices are equal. It has bilateral symmetry. It has a distinct left side and a right side. This is the body plan of an advanced animal, a bilaterian, like us. 2. The gut sea anemones, cnidarians, have a blind gut. It's a sac. Food goes in the mouth, and the waste comes back out, the same hole. It's a two-way street. But Echinacea, it has a complete gut. It's a one-way tube. 3. The impossible. Feature. A one-way tube means it has a mouth at one end and a separate anus at the other. As the video so bluntly puts it, it has a butt. This is the chimera. This is the problem. Echinacea is a simple sea anemone with the advanced body plan of a complex bilaterian. It breaks the classification. The invention of a through gut and an anus is one of the single biggest leaps in the history of evolution. It separates the simple animals, sponges, jellyfish, from all other animals, worms, insects, humans, and Echinacea is both. It's a simple animal with the advanced digestive system tacked on. It's a fossil that should not exist. It's a Y-shaped impossibility. These alphabet animals from Mazon Creek are true evolutionary one-offs. They are ghosts from a time when evolution was still tinkering with body plans, 200 million after the Cambrian. But there's another fossil from a different Carboniferous formation that is so strange, so alien, that scientists didn't just nickname it. They gave up on it. They put it in a drawer for 30 years because nobody wanted to deal with the headache of trying to figure it out. Meet the alien goldfish. The alphabet animals of Mazon Creek are problem fossils, but at least we have them. We have thousands of them to study and argue about. But there's another fossil from a different Carboniferous trap that is so strange, so featureless, and so alien that it represents a completely different kind of puzzle. You are now in the Bear Gulch Limestone Formation in Montana. This is another Lagerstätte, like Mazon Creek, famous for preserving the soft bodies of 330-million-year-old creatures. In the 1970s, scientists found a fossil here, and when they found it, they nicknamed it the alien goldfish. And then they ignored it. This is our quirky tidbit for the night. This fossil was so profoundly weird, so lacking in any recognizable features, that, as the video transcript states, it went unreported for a very long time, as no one wanted to deal with the headache of trying to figure out what it was. It was a fossil so problematic that the entire field of paleontology collectively put it in a drawer for 3 decades and pretended it didn't exist. This is Typhlosus. You're looking at it now. It's a spindle-shaped blob. That's it. The headache was in what it didn't have. It has no midsection. It has no gut, at least not a through gut. It has no anus. It has no external appendages, no fins, no arms, no tentacles, except for a single tail fin at the back. It is a streamlined blob with a tail. Except for one thing. Inside its body, it has a unique, complex organ. An organ that has never been seen before or since in any animal in the 3.5 billion year history of life on Earth. It is called the Ferroiscus. This scientific evidence is the core of the mystery. The Ferroiscus is a distinct sac-like organ that, when analyzed, shows massive concentrations of iron. This, of course, is the great scholarly debate. What is it? Was it a sensory organ, allowing Typhlosus to navigate by sensing the Earth's magnetic field? Was it a liver or a spleen processing iron? Was it just ballast? A weight to keep the blob oriented in the water? We have no clue. It's a spare part from an alien that evolution threw away. For a brief, shining moment, scientists thought they had solved Typhlosus. They found a new specimen that had teeth. Specifically, conodont-like teeth. Conodonts were a group of jawless, eel-like vertebrates. The teeth matched. The mystery was solved. Typhlosus was a conodont. Until a very clever researcher looked closer. The teeth were not in its mouth. They were inside its gut. It wasn't its teeth. It was its last meal. This aha moment was a back-to-square-one disaster. The discovery only deepened the mystery. It proved Typhlosus was a carnivore. It ate conodonts. But it told us nothing about what it was. The alien goldfish was, once again, a homeless blob. Though, as the video notes, a 2022 study did propose it was a mollusk, arguing it had a toothy tongue, a radula. But just like the Tully War, this is now hotly contested, as radulas may have evolved multiple times. Typhlosus tullimonstrum esconasia. These unclassifiable blobs from the Carboniferous prove that the weirdness of the Cambrian never really ended. Evolution never stopped tinkering and creating WTF fossils. But while these blobs were busy confusing future scientists, other branches of life, branches that were classifiable, were evolving in a very different and very terrifying direction. The arthropods were about to take over. You're leaving the Carboniferous swamps with their alphabet animals and Tully monsters and traveling back in time. We're going to the Silurian period, 430 million years ago. The world is settling down. The Great Ordovician Biodiversification event, that Explosion 2.0, has filled the seas. Life is now complex, varied, and competitive. The age of fishes is just dawning. You can see the first small, jawless, armored fish. Ostracoderms, mud-sucking on the seafloor. But the rulers of this ocean, the apex predators, are not fish. You're in a shallow, brackish estuary where a river meets the sea. You see a shadow scuttle out from under a rock. It looks like a scorpion. A scorpion the size of a kayak. You've just met a Eurypterid, the sea scorpion. These are not fish. They are arthropods, in the same family as modern spiders, scorpions, and horseshoe crabs. And in the Silurian, they were kings. They are tanks. Their bodies are covered in a hard, chitinous exoskeleton. They have regular walking legs, but their back pair of legs has been modified into giant swimming paddles, which they use to fly through the water. And at the front, they don't have hands. They have two massive pinchers, or chelicerae, just like a modern scorpion. Most Eurypterids were small, maybe a foot or two long, hunting fish and trilobites in the shallows. But one was not small. You're looking at it now. It's Dickinsonia, and it is 8.2 feet long. This is our mainstream historical fact for the night, and it's a big one. Dickinsonia is the largest arthropod that has ever lived. Ever. In 3.5 billion years of life, this is the peak of Incertum. Imagine a sea scorpion the size of a crocodile, with paddles and pinchers. This was the new apex predator. The throne that Anomalocaris left empty after the Cambrian was finally filled. Dickinsonia was the terror of the Silurian and early Devonian, and it was adaptable. We find its fossils not just in the ocean, but in brackish, partly salty estuaries, and even freshwater rivers and lakes. It was invading the land long before the fish were. This, of course, leads to the great scholarly debate. How did an 8-foot-long crocodile scorpion hunt? Hypothesis 1. The trawler. Some scientists argue it was a bottom feeder, using its walking legs to trawl the muddy bottom of the river, using its pinchers to feel for prey, like fish or other Eurypterids, hiding in the mud. Hypothesis 2. The ambush predator. Other scientists argue this is too passive for a creature so large. They believe it was an ambush predator. It would bury its 8-foot-long body in the mud and wait until a large fish swam overhead, and then lunge, snatching the fish from the water with those giant spiked pinchers. And for our quirky tidbit, let's talk about the tail. Eurypterids are called sea scorpions because their tail, the telson, is long, segmented, and shaped exactly like a scorpion's stinger. But was it a stinger? For decades, this was the assumption. Of course, it was a venomous stinger, but the stinger itself is blunt. It's not a hypodermic needle, like a modern scorpion's. The current consensus is that for most sea scorpions, the stinger was not venomous. It was just a rudder, a tail fin to help it steer while swimming. However, this debate is not closed. Some scientists still argue that some species, maybe Dickinsonia, could have used it as a stabbing weapon, or that it did have a venom gland. The stinger remains a question mark. The Eurypterids, these crocodile-sized sea scorpions, were the terror of the shallows and the rivers. But out in the deep open ocean of the next period, the Devonian, a new kind of armor was rising. The age of fishes was really about to begin, and it had a bite. The crocodile-sized sea scorpions ruled the shallow rivers and estuaries. But out in the deep, open ocean, a new arms race was in full swing. You are now in the Devonian period, 370 million years ago. This is, famously, the Age of Fishes, and the kings of this age, the new apex predators, were not fish as you know them. You're not looking at a sleek, fast shark or a tuna. You're looking at a living tank. You've just come face to face with Dunkleosteus. This is a placoderm, an armored fish. And armored is an understatement. This is a dreadnought battleship. The entire front third of this creature's body, its head and shoulders, is encased in massive, thick, interlocking plates of solid bone. It is a living 20 to 30 foot long battering ram. This head shield was impenetrable. It was a walking, or swimming, fortress. But here's the weird part. You're looking at this 30-foot-long terror fish. The back 2/3 of its body is gone. This is our quirky tidbit for the night, and it's one of my favorites. We have never found the body of a Dunkleosteus. Not once. We have only found the head shield. Why? Because the entire back half of the fish, its spine, its tail, was not bone. It was soft cartilage, just like a modern shark. And cartilage does not fossilize. This means that every single reconstruction you have ever seen of Dunkleosteus, that shark-like tail, those fins, is a complete guess. A best guess based on its smaller and more complete placoderm cousins, but a guess nonetheless. For all we really know, it could have had the back end of an eel, or a tuna, or, probably not, a tadpole. The only part of this king that survived time was its impenetrable fortress head. This leads to the great scholarly debate that still rages. Paleontologists still argue whether the placoderms, this entire class of armored fish, were a true evolutionary lineage, or just a failed experiment. They were top-of-the-line armor, in a world that was pivoting to speed, sharks, and adaptability, the bony fish. Our line? Were they the knights in shining armor, in a world that was inventing gunpowder? But the armor isn't even the scariest part. You swim up to the face of this 30-foot-long head tank. You look at its mouth. It has no teeth. This is the scientific evidence that makes Dunkleosteus a nightmare. It doesn't need teeth. Instead, the bone plates of its jaw grew down into massive, sharp, self-sharpening beak blades. It was a guillotine. It didn't chew, it sheared. Its jaw was a pair of bone scissors. And the way it used this guillotine, the mechanics of its bite, was just as strange and as terrifying as its bone teeth. The bone blades of Dunkleosteus were a terrifying innovation, but the way it used them is what makes it a true masterpiece of biomechanical horror. Scientists, by studying the joints and pivot points on that fossilized head shield, have been able to create biomechanical models of how its guillotine jaw actually worked. And it's unique. It's not a simple hinge jaw, like yours. Dunkleosteus had a complex 4-bar linkage jaw. This is a mechanics term, but here's what it means in practice. When Dunkleosteus decided to open its mouth, it didn't just drop its lower jaw. The entire mechanism of its face moved. As the lower jaw, the blade, dropped down, a separate set of joints also lifted its entire skull, the top of its head shield, up, at the exact same time. Why invent such a complex 4-part opening system? One reason: speed. This 4-bar linkage allowed it to open its massive guillotine mouth in 1/50th of a second. It was an explosion. It wasn't a bite. It was an implosion. This instant open mechanism created a massive suction void. Dunkleosteus didn't chase down its prey. It just got close. And then it opened its mouth. The vacuum sucked the water, and the prey, other armored fish, early sharks, giant sea scorpions, into its mouth, before the guillotine snapped shut. And that snap, this is the second part of the equation. The force. The suction brought the prey in. The snap finished the job. Models of its jaw-closing muscles, which were massive and anchored to the back of that giant head shield, calculated the bite force at the tip of its bone blade. The answer is 8,000 pounds per square inch. This is one of the most powerful bites in the history of life on Earth. It is stronger than a modern great white shark. It is stronger than a T-Rex. It was enough force to shear anything in the Devonian Ocean. It snipped other armored fish in half. It crunched sharks. This was a terror fish that ate everything. This is our mainstream historical fact for the night. We know it was a terror because we have found Dunkleosteus head shields with Dunkleosteus bone blade marks on them. They were vicious. They were cannibals. This king of the Devonian, this living guillotine, was the undisputed ruler of the sea for 20 million years. It was the peak of the Placoderm dynasty. And it was too specialized. Dunkleosteus was a Formula One race car. It was designed for one job, killing armored prey, in one environment, the open water Devonian Sea. And when the environment changed, it crashed. At the very end of the Devonian, a new mass extinction event, the Hungenberg event, hit. We're not sure of the cause. Maybe sea level change, maybe anoxia, the ocean losing its oxygen. But whatever the cause, the effect was catastrophic. And the first to go were the specialists. The entire dynasty of placoderms, the armored fish, all of them, including Dunkleosteus, were completely wiped out. They vanished. The age of armored fish was over. And who won? Who survived this extinction? The weaker fish. The unarmored cartilage fish, the sharks. And the small, adaptable bony fish, our line. The knights in shining armor, the placoderms, all died in the war. And the unarmored, fast-moving archers, sharks, and the humble hiding peasants, our bony fish ancestors, inherited the entire kingdom of the ocean. The sea was a battleground of armor and bone blades. But while this war was raging, something new, something revolutionary, was happening on the edges of the world. The land, which for billions of years had been sterile rock, was for the first time turning green. You are leaving the Devonian Ocean with its guillotine fish and its surviving sharks. You are now moving forward in time, back to the Carboniferous Period, 320 million years ago. But this time, you are not in the water. You are on land. For the first time in our journey, the land is alive. It is green. But it's just as alien as the Ediacaran seafloor. This is a preview of a world without flowers. There are no flowers. There are no pine trees. There are no oaks or maples. The forests you are standing in are not trees as we know them. The canopy 100 feet above your head is made of lepidodendron, a giant club moss. The bushes and undergrowth are giant ferns, sphenopsids. This is a swamp of spores, A global coal swamp, as this vegetation will one day become the coal that fuels our industrial revolution. But the plants are not the key ingredient of this world. The air is. This is our mainstream historical fact. All of these massive global coal swamps are photosynthesizing, and they are pumping billions of tons of oxygen into the atmosphere. The air you are breathing is not to the 21% oxygen mix of today. The atmosphere of the Carboniferous is 35% oxygen. You can feel it. The air is thick, it's heavy, it's rich, and it is incredibly flammable. The slightest spark from a lightning strike would not start a forest fire. It would start an explosion. Wildfires in this oxygen-rich world would have been apocalyptic. This super-oxygenated air solves a problem, a big biological problem, for the arthropods, the insects and spiders. This is the scientific evidence behind the Age of Monsters. An insect, like a modern beetle, doesn't breathe with lungs like you do. It breathes passively. It has a series of holes in its body, called spiracles, which connect to a network of tiny tubes called trachea. The oxygen in the air just diffuses down these tubes into its body. This system is wildly inefficient. It's the reason why insects today are small. An insect can't get big, because the oxygen can't diffuse far enough or fast enough down those tubes to power a large body, unless the air itself is 35% oxygen. In this world, this inefficient tube-breathing system works. It works so well that the size limit on insects is broken. The problem is solved, and the solution is gigantism. You hear a noise in the undergrowth of the giant ferns. It's a skittering sound, a rustling. But it's not a rat. It's not a lizard. It's heavy. It's the size of a car. That sound in the undergrowth is the king of the Carboniferous forest floor. You're looking at Arthropleura. It's a diplopod, a relative of the modern millipede. But it is 8.5 feet long and 3 feet wide. This is not an exaggeration. This is our mainstream historical fact of the night. Arthropleura is the largest land-dwelling invertebrate of all time. It is a segmented, armored arthropod the size of a smart car or a small crocodile. You're watching it crawl through the coal swamp forest. It's a living tank. Its armor is thick and durable. And we know it was here. We don't just have its body fossils, we have its footprints. This is the scientific evidence that cements its legend. All over Europe and North America, we have found its fossilized trackways. They are called diplocnites, and they are massive. They are two parallel lines of footprints, sometimes feet wide, marching across 300-million-year-old mudstones. It's the track of a monster. But what did this car-sized millipede eat? This is the great scholarly debate that splits the paleo community. Hypothesis 1, the gentle giant herbivore. For decades, this was the accepted truth. Arthropleura was a gentle giant. It was a detritivore, a trash eater. It crawled slowly through the swamp litter, munching on rotting club mosses and ferns. The evidence for this? We found fossilized spores, the pollen of this era, in its gut tract. Hypothesis 2, the nightmare, carnivore-omnivore. But this theory has a problem. Modern millipedes are herbivores, but modern centipedes, its close cousins, are vicious carnivores with poison fangs. We have not found the mouth parts of Arthropleura. What if they were sharp, centipede-like fangs? And those spores in its gut? Well, pollen gets on everything in a swamp. Maybe the spores were just contamination, stuck to the outside of the other animals it was eating. This hypothesis paints a very different picture. It pictures an 8.5-foot-long armored ambush predator, a centipede the size of a crocodile, hunting giant scorpions and large amphibians in the undergrowth. The debate is hotly contested, but whatever it ate, herbivore or carnivore, one thing is certain. This is our quirky tidbit. Arthropleura had no known predators. It was too big, too armored. It was the king of the forest floor. Nothing hunted it. It was an invincible, friendly, or not so friendly, giant, walking fearlessly through the spore-filled air. Arthropleura ruled the ground, but the air, that thick, rich, 35% oxygen air, belonged to something else. You hear a noise, not a skittering, a sound from above your head. A low, fast, whum, 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 like a remote control drone. That whum, whum, whum sound is the terror of the Carboniferous sky. You look up, and flying, or flitting menacingly, through the giant fern trees, is Meganeura. This is the giant dragonfly. Though to be technical, it's a griffinfly, a close relative, not a direct ancestor of modern dragonflies. And it is enormous. It has a 2.5-foot wingspan. This is the size of a modern-day seagull, or a crow. It is an insect the size of a bird of prey. This is the poster child for the high oxygen theory. This is our scientific evidence. Meganeura is the living proof of that 35% oxygen atmosphere. Its inefficient, passive, tube-breathing system, the spiracles and trachea we talked about, only worked because the air was so rich. It was supercharged. And what was this seagull-sized insect doing? It was hunting. This is our mainstream historical fact. Meganeura was the Anomalocaris of the sky. It was Earth's first aerial apex predator. It was a voracious hunter. You're watching it now. It patrols the coal swamps, its giant eyes scanning for prey, other large insects, scorpions, or even small amphibians, the first vertebrates on land. And for our quirky tidbit, how did it hunt? It didn't catch prey with its mouth. That's inefficient. Like a modern dragonfly, it cupped its 6 spiny legs into a catching basket. It would swoop down, snatch its prey, like a large lizard, out of the air with its leg basket. And then, without even landing, it would bring the squirming prey up to its mouth and eat it while still flying. It was an aerial terror, a 3-foot-wide, flying leg basket of death. So, what happened to them? What happened to this age of giant insects? Why aren't we ducking from seagull-sized dragonflies today? The world changed. This is the great scholarly consensus. The Carboniferous Period ended. The climate shifted. It became cooler and drier. Those massive global coal swamps dried up. And when the swamps died, the oxygen factory shut down. The atmospheric oxygen level began to drop. It plummeted from its high of 35% back down to levels closer to our modern 21%, and at one point, even lower. And for the giant arthropods, this was a catastrophe. Their inefficient tube-breathing system, which had been their greatest strength, suddenly failed. It could no longer pump enough oxygen to power their giant bodies. They suffocated. The giants, Arthropleura, Meganeura, went extinct. The age of giant insects was over. Not because of a predator, but because they could no longer breathe. The arthropods, after ruling the sea scorpions, and the land, the giant insects, had finally lost their throne. Their dynasty was over, and a new group, a group that had been hiding in their shadows, was about to take the land. A group with a new innovation. Lungs. Our group. The synapsids. The almost-mammals. The age of giant insects is over, drowned in an atmosphere that could no longer support it. The arthropods, after their long reign, have lost the land. And into this power vacuum, a new group of animals invades. This group has been hiding in the shadows of the coal swamps, the tetrapods, the four-legged vertebrates that crawled out of the sea. You are now in the Permian period, 280 million years ago. This is before the dinosaurs, and the world is ruled by our family. You see one of them now, sunning itself on a rock. It's an animal you recognize instantly. It's Dimetrodon. And this is our mainstream historical fact of the night, and it's the most important one I can give you. Dimetrodon is not a dinosaur. I repeat, it is not a dinosaur. It's not even a reptile, at least not in the way we think of one. This is a classic mistake in every child's toy bin. It lived and died 40 million years before the first dinosaur ever evolved. So, what is it? It's a synapsid. This is a key concept. Life on land split into two great dynasties, based on the holes in their skull behind the eye, for jaw muscles. The diapsids, two holes. This line would lead to all reptiles, lizards, snakes, crocodiles, and dinosaurs. The synapsids, one hole. This line, our line, would lead to all mammals, including us. Dimetrodon is a synapsid. It is on our side of the family tree. That 15-foot-long, sprawling, fanged predator is not a dinosaur. It is a distant, primitive cousin of you. It is an almost-mammal, and it was the apex predator of its day. But its most famous feature is its greatest mystery. The sail. This is the great scholarly debate. What was this massive, 5-foot-tall sail on its back? 4. It's not armor. It's just its vertebrae, its backbones, grown up into massive, thin spines with a web of skin stretched between them. It was fragile. So why have it? Hypothesis 1. Thermoregulation. The solar panel. This is the classic theory. Dimetrodon was cold-blooded, or partially warm-blooded. It was living in a world with cold mornings. So in the morning, it would turn its sail sideways to the sun, using it as a giant solar panel. The blood rushing through the sail would heat up fast. It could raise its body temperature in minutes, while its prey, other reptiles and synapsids without sails, were still cold and sluggish. It was a solar-powered predator. Hypothesis 2. Display. The peacock. This is the other major theory. It was just display, like a peacock's tail. A big, colorful sail meant you were a healthy, strong male. It was a billboard for attracting mates. So, which one is it? A radiator or a billboard? For our quirky tidbit, we have a clue. We have found Dimetrodon fossils where the long, thin sail spines are broken and then healed. Think about that. For a broken bone to heal, it needs a massive, constant supply of blood, carrying nutrients and calcium. The fact that these spines could heal is our smoking gun. It proves that the sail wasn't a dead thing like a fingernail. It was full of blood vessels. It was a living, blood-rich radiator. This evidence swings the pendulum strongly towards the thermoregulation, solar panel theory. Dimetrodon was an early, sprawling attempt at a synapsid predator. But it was just the beginning. By the end of the Permian, this new dynasty, our dynasty, had evolved into something new, something fast, something warm-blooded, something truly terrifying. Dimetrodon was an early solar-powered experiment, but you are now moving to the late Permian, 260 million years ago, and the experimental phase is over. The synapsid dynasty, our dynasty, is now in full control of the planet. You are in a dry, cool forest, and you see the new apex predator. This is not a sprawling lizard-like Dimetrodon. This is a gorgonopsid, a creature like Inostransavia, and it is a beast. You're looking at a predator the size of a bear or a Siberian tiger. And the first thing you notice is its posture. Its legs are not sprawling out to the sides, like a lizard's. They are directly under its body, just like a wolf's or a lion's. This is scientific evidence of a monumental leap in evolution. This is not a waddler. This is a runner. This is a creature built for speed and power. And then, you see the teeth. This is the first animal on Earth to invent saber teeth. You see its massive, 5-inch-long, dagger-like canine teeth. They are so long, they slide past its lower jaw when its mouth is closed. This is a killing machine, designed for one purpose: to plunge those daggers deep into the throat of its prey. This is the Gorgon. It was the undisputed apex predator of the late Permian. And this leads us to our mainstream historical fact of the night. And it's a mind-bender. This entire ecosystem, the world of the late Permian, was not a reptile world. It was a mammal-like world. The rulers, the apex predators like the gorgonopsids, the large herbivores they hunted, the echidodonts, were all synapsids. They were our cousins. And the dinosaurs? Where were they? Their ancestors, the diapsids, were here. They were the small, insignificant, lizard-like creatures, hiding in the bushes. They were the prey. They were the ones living in terror of our saber-toothed gorgonopsid family. The roles were completely reversed. And for our quirky tidbit, how do we know they were so mammal-like? We've looked at their skulls, and on the snout bone of gorgonopsids, we have found clusters of tiny pits, or foramina. These pits are identical to the pits in a modern cat's skull, the pits that house the nerves and blood vessels for whiskers. This was a saber-toothed killer, with whiskers. Whiskers imply a highly tuned sense of touch. They imply a nocturnal hunter, and a nocturnal hunter implies it was warm-blooded. This wasn't a solar-powered Dimetrodon waiting for the sun. This was a true, high-metabolism, engine-running, warm-blooded killing machine. It was, in all but name, a mammal. This dynasty, our dynasty, had won. They ruled the world. They were on top. And then, in a geologic instant, everything died. The synapsid dynasty, our dynasty, was at its absolute peak. The gorgonopsids, our warm-blooded, whiskered, saber-toothed cousins, were the undisputed masters of the planet. They had won. The age of almost mammals was in full swing. And then, the world ended. You are now 252 million years in the past. You are bearing witness to the Permian Triassic extinction event. It is not an extinction. It is the extinction. It is known, quite simply, as the Great Dying. What caused it? This isn't a mystery like the end of the dinosaurs. The scientific evidence is brutal and clear. The culprit was volcanoes. Not a volcano. Not a Mount St. Helens. You are in what will one day be Siberia. And the ground has split open. This is the Siberian Traps, a fissure in the planet's crust so large that it bleeds lava, not for a day or a week, but for 1,000,000 years. This is an apocalypse that unfolds in slow motion. For 1,000,000 years, this eruption pumps billions of tons of carbon dioxide, methane, and sulfur dioxide into the atmosphere. It triggers a runaway greenhouse effect. The planet's temperature soars. The oceans turn acidic from the CO2, dissolving the shells of marine life. Then the ocean currents stall, and the warm, acidic water loses its oxygen. It becomes anoxic. The toll. This is our mainstream historical fact, is unimaginable. This is the closest life on Earth has ever come to being completely erased. 95% of all marine species vanish. The oceans are left virtually empty. 70% of all land species vanish. The forests die. The world is left a toxic, scorched wasteland. And the rulers of this world, the winners, the great Synapsid dynasty, they are the biggest losers. The early experiments, like the sailback Dimetrodon dynasty, long gone. And the apex predators, the saber-toothed warm-blooded Gorgonopsids, are annihilated, wiped off the face of the planet. Their entire dynasty gone. So now who survived? Who inherits this empty, scorched Earth? Not the strong, not the apex predators. The lucky, the small. The ecological afterthoughts that could hide, burrow, and eat anything. This is the great twist, our quirky tidbit. Our own direct line. A tiny, shrew-like burrowing synapsid called a cynodont barely survives. It clings to life in a hole in the ground. And the other lucky survivors? Those small, insignificant, lizard-like diapsids, the reptile line, the ones that had been hiding from the Gorgonopsids for millions of years. They survived too. The Great Dying wipes the slate clean. It violently ends the age of almost mammals. The world is now empty. And those lucky surviving reptiles, the diapsids, are now staring at an empty planet with all of their predators, our family, gone. They are about to explode into this vacuum. The age of reptiles, the age of dinosaurs, is about to begin. But the recovery was weird. The Great Dying has wiped the slate clean. Our dynasty, the Synapsids, is gone. The age of almost mammals is over. You are now in the Triassic period, the dawn of the age of reptiles. This is the recovery. And it is weird. The world is a bizarre, post-apocalyptic evolutionary workshop. The planet is empty, and those lucky diapsid, reptile line survivors are exploding into the vacuum, experimenting with wild, off-the-wall body plans. The world is a blank canvas, and evolution is throwing paint at it. You're standing on a beach in what will one day be Switzerland, and you see one of these new experiments. You see a creature basking on a rock. It's about 20 feet long. It's an archosaur, a ruling reptile, a distant cousin of the dinosaurs and crocodiles that are about to evolve. And then you realize 10 feet of that 20-foot length is just its neck. You are looking at Tanystropheus, the creature with the most laughably, impossibly, structurally unsound neck in the history of life. Let's be clear about this neck. It's not like a Brachiosaurus or a Diplodocus, long-neck dinosaurs, which get their length from having lots of small vertebrae, like a string of pearls. Tanystropheus gets its 10-foot neck by having just 13 massive, elongated, broom-handle vertebrae. It's not a flexible snake. It's a rigid, stiff pole with a tiny, tiny head stuck on the end. How did this thing live? How did it walk around without snapping its own neck? How did it hold its head up? This is one of the biggest scholarly debates in paleontology. Hypothesis 1. The terrestrial theory. The ambush predator. For a long time, we thought it was a land dweller. It would hide its big, 20-foot body in the bushes, on the shore, and then use its impossible 10-foot neck to snake out, like a living catapult, and ambush prey, like insects or small lizards, that got too close. A 10-foot strike range. Hypothesis 2. The aquatic theory. The fishing rod. But that neck is so rigid, and its body is so heavy. The new theory is that it was aquatic or semi-aquatic. It spent most of its time in the water. Its heavy body would float, and that long, stiff neck would act as a living fishing rod. It would drift silently through the lagoons and just dart its tiny head down to snatch fish and squid, which wouldn't even see the predator 10 feet away. So, which is it? A land catapult or a water fishing rod? In 2020, we got our smoking gun. A team of scientists took a perfectly preserved Tanystropheus skull and put it in a CT scanner. This is our new scientific evidence. The scan allowed them to reconstruct the skull in 3D, and they found its nostrils were not on the front of its snout, like a lizard's. They were on the top of its snout, just like a crocodile's. This is a classic adaptation for an aquatic animal. It allows you to breathe while the rest of your face is underwater. This is strong evidence that the aquatic fishing rod theory is the correct one. And for our quirky tidbit, the CT scans revealed something else. The babies, the juvenile Tanystropheus, had completely different teeth than the adults. The babies had sharp, pointed, insect-stabbing teeth. The adults had 3-pronged, fish-catching teeth. This suggests they completely changed jobs as they grew up. The babies, who were small, with short necks, were terrestrial, running around on the beach, eating insects. And then, as they grew, and their neck became a 10-foot pole, they moved into the water and became full-time fish hunters. Tanystropheus, the two animals in one, is the perfect example of the bizarre experimentation of the Triassic. But this strangeness didn't stop when the Triassic ended. It continued, even when the dinosaurs were in full swing. We just have to look at one of the weirdest dinosaurs ever found. The impossible neck of Tanystropheus was a hallmark of the Triassic recovery, a time of bizarre experimentation. But this weirdness didn't stop once the dinosaurs took over. Evolution never stops tinkering. You are now in the late Cretaceous, 70 million years ago. This is the end of the Age of Dinosaurs. The greatest hits are all on stage. Triceratops is browsing in the fern prairies. T-Rex, or its close Asian cousin, Tarbosaurus, is the apex predator. The world is stable, mature, and then you see this thing. You're looking at Therizinosaurus, the scythe-lizard. Now, to understand why this creature is so bizarre, you have to know its family. This is a theropod. It is in the exact same family as Velociraptor and T-Rex. It is by blood, by lineage, a meat-eater. Except, it's not. You're looking at a nightmare of contradictions. This T-Rex cousin has a tiny, tiny head on the end of a long neck with a toothless beak, and the teeth it does have in the back of its mouth are small, leaf-shaped. Plant-eating teeth has a massive pot-belly gut. This isn't the gut of a carnivore. This is a giant fermentation vat, just like a cow's, designed to slowly digest massive amounts of tough plants. Has short, stumpy legs with 4 toes on the ground. It is slow. It's a waddler. This is an evolutionary paradox. It is a member of the meat-eating, fast-running predator family that has evolved to be a slow-moving, pot-bellied, long-necked vegetarian. It is the dinosaur equivalent of a wolf deciding to become a panda. And then you see the claws. This is the mainstream historical fact. On its hands, its long 3-fingered arms, are claws. No, not claws. Scythes. Each claw is 3 feet long. These are the longest claws of any animal, ever in the history of the planet. So, this is the great scholarly debate. What is a slow, pot-bellied vegetarian doing with 3-foot-long Freddy Krueger claws? Hypothesis 1. Defense. This is the obvious one. When the local T-Rex Tarbosaurus comes sniffing around, a set of 6 3-foot-long switchblades is a pretty good deterrent. It's a message that says, go eat something else. Hypothesis 2. The sloth dinosaur. Feeding. This is the more recent and more fascinating theory. Look at the Therizinosaurus. It's too big and pot-bellied to be a low-to-the-ground grazer, like Triceratops. And it's too slow and stumpy to be a high browser, like Brachiosaurus. It's in an awkward middle zone. So, how does it eat? In this theory, it was an evolutionary sloth. It would waddle up to a tree, rear back on its sturdy legs, and use those 3-foot-long claws not as weapons, but as rakes. It would hook them onto massive branches and pull the branches down to its tiny beaked mouth. And for our quirky tidbit, for decades, we only had the claws. Just the claws. We had no idea what they belonged to. Scientists in the 1950s thought they were the ribs of a giant 30-foot-wide turtle. Therizinosaurus is the perfect place to end our journey. It proves that evolutionary strangeness isn't just a primitive thing. It's not just confined to the Cambrian weirdos or the Carboniferous blobs. Evolution never stops experimenting. It never stops being weird. The 3-foot claws of the sloth dinosaur, the 10-foot neck of the fishing pole reptile, the guillotine face of Dunkleosteus, the 5 eyes of Opabinia, and the unclassifiable mystery of the Tully Monster are all part of the same grand, baffling, and beautiful story. And now our journey through this cabinet of curiosities comes to a gentle close. The lights in the long museum hallway are dimming, one by one. The Age of Monsters, with its cacophony of bone blades and giant dragonfly wings, fades into a respectful silence. The Age of Unclassifiables, with its confusing blobs and alphabet animals, feels less like a headache and more like a soft, unanswered question. a riddle that can wait until morning. The strangeness of the past isn't really strange at all. It's just life. It's the record of 1 billion frantic, beautiful, and failed experiments, all running their course in the deep, quiet laboratories of time. We are just one of those experiments. The one that, by sheer dumb luck, worked. The one that survived the filters, the freezes, and the fires. The one that gets to be here, now warm and safe. And remember all the ghosts that came before. The halls are empty now. The fossils are still. The 3-foot-long scythes of the Therizinosaurus are just shadows on the wall. The time-traveling Nectocaris is just a faint impression in shale. And 2.1 billion years ago, the Francevillian flowers are just, perhaps, crystals, forming in the mud, in a world that is falling into a 1 billion-year-long sleep. It's time for us to do the same.